Okay, last but not the least, this is WP5. Most of the the agenda is only myself, so I don't show it. It's gonna be 5 minutes, not more. So I wouldn't bother you so much with this. Just the only thing to say is that the most of the implementation of WP5 activities has been explained in WP3. So that's the reason why WP3 training sessions are quite so long. Okay, so that's the only thing that was left out in the WP5 implementation, and is the implementation of the well, in seamless or interoperability. Okay, so what we have done inside AMASS, well, I have to say that it is on not only TRC, but it is TRC in collaboration with the University Carlos III of Madrid put together. Okay, and our goal here has been to generate a new way of interconnecting tools with a mass platform. Okay, we came, well, this is a little bit agenda, but I'm going to, well, we came from the previous project where OSLC, Open Standard for Life Cycle. Let's say that in the end, the other ones, such as the AMASS platform, and those those applications cover different domains, solve different type of problems, and generate different type of artifacts. Okay, a kind of intelligent environment. So there is a need of interoperability inside the same domain or inter-domain, different domains producing different types of artifacts. Is that this OSLC, okay, this standard tries to cover that necessity, trying to generate several standards, several flavors to deal with every domain that is included in this standard. Okay, so that's the situation, and the implementation is via linked data. Okay, now we discovered that in the end, this collaboration, it was, let's say, almost point-to-point connections with this standard, but depending on the source and target tool, some kind of connector, special connector has to be done because the the background of each standard, the contents of the instances of the standard was represented different things depending on the domain, even though they were represented by the same, for example, terms or wording. Okay, so that's where OSLC KM, OSLC Knowledge Management, appears, and this is our contribution to the seamless interoperability. We have defined this standard, and this standard is generating a representation of the language included in those OSLC connections. Meaning that one term that, for example, if you use aircraft in one instance of OSLC standard in any flavor, means that when you are referring to aircraft in any other instance of other flavor of the OSLC standard, means exactly the same. Okay, so we have the background that everything fits together. So you don't have any kind. Okay, this term means here something, but within the other domain there is a slight difference. So, and it does not match perfect from one flavor to another. So there was a gap, and this OSLC KM is what it tries to cover. Okay, so the OSLC KM, as you can see here in the slide, is composed of several items. The first one is the resource shapes, like in OSLC. Okay, we have this way of representing this knowledge, and we call system representation language, or SRL, RL. And with that language, we have two types of items represented. Domain artifacts is representing the different content of each OSLC flavor in the same with the same background. Okay, so we call system artifact, in fact, and what it gives it coherence behind is the system knowledge base. Over everything represented here has the definition in here in the knowledge base. Okay, and finally there are delegated operations just to see definitions of terms. If you are in one tool and you want to know what does this aircraft means, there you can call this via OSLC KM a delegated interface, so you can get the definitions and the synonyms, etc., etc. Okay, and this is the definition of the meta model of the system, or model of the system representation language. Okay, we try. It's very similar to the AMASS model for defining evidences. Okay, it's very similar. Some extra entities here on top of it before calling can reference the artifact. We call here artifact, whereas in the AMASS platform is artifact, but anyway, it's the same. Okay, it's the same. You can do a mental mapping from one to the other almost. And now you can see here what we pretend to do to demonstrate the seamless interoperability within the AMASS platform and in this case our tools, the tools of TRC. Okay, we pretend that from the AMASS platform we will be requesting evidences to an external tool, in this case requirements quality analyzer or system quality analyzer, as you can see in the session of Webpack 3 this morning. Okay, and this external tool will generate this system representation language, the instance of this model, and we will be ready to the AMASS platform to perform whatever activity inside of it. For example, storing them as evidences within the evidence manager of whatever assurance project that we have. Okay, and the other situation is that the external tool directly generates the system repository language and stores it in a AMASS platform. In our case, it will be system quality analysis that generates the quality assessment as evidences in this language, and we can store it within a AMASS platform as evidences for certificate that my system has has gone through this quality review process, requirements quality review process. For example, requirements or whatever type of product. Okay, this is the target situation we are going to have at the end of the AMASS project, and the current situation is that we have only developed the first one. The thing is not as perfect as we would like, but we didn't have so much time to cover the usability that we would like to have, but we are going to cover this gap in this next prototype. And well, this is the situation, and now I'm going to do a very brief demo. Okay, so I have here the AMASS platform, and what we have generated for this prototype is to generate this menu. Okay, here you will find some things from WP5, but they are not quite finished. They will be shown in the next prototype when they are finished completely. They didn't want to show in the training because they are not they are functional, but they are not like they want. Okay, but the demonstrator for WP5 is here. As I tell you, it's a demonstrator, and the idea is what we have implemented is that, okay, for this iteration, please give us an evidence in the shape of a papyrus file. Of course, we have to implement here some nice features to copy, to select the file and so on. We didn't have time for that. We wanted only to focus on the functionality only. And here, have here the path, okay, and then you select the the papyrus file, which is containing the evidences. Then, but a papyrus model is not an evidence as it is. So what we are doing here is to generate a request for an evidence out of the content of this papyrus file. It will call the web service we have published in our public servers to convert this content of the papyrus file into evidences, and these evidences are as instances of this system representation language. And then this, as we have the output of this system representation language, we can do it whatever we want here in AMASS. And what we have done is as follow. Well, we have published this URL. It's common for everybody. So just you give the papyrus file, it will generate the evidences. And our idea for next prototype is to give it much more user to be much more user friendly, with much more functionalities to select the file, to select the target project where you want to store the evidences, and so on. Here is just a demonstrator. So if I click on finish, now it is getting the papyrus file content, sending to the web service, and when the web service has just returned the instance. And now inside the AMASS platform, we have created the parser of that system repository system representation language, and then out of that representation we have mapped, as I said in the beginning, the SRL with the evidence manager model. We have make a transformation of the data, and we store it here in a predefined position within the repository. This is something to be improved. Okay, and as a result, you can see here, this is a very, very small example, but you can see here that we have generated one artifact composed of many sub-artifacts, okay, which holds a kind of relationship between other artifacts. For example, we have an artifact here with a generic relationship between an structure requirement and the frame, and so on. And here you have the content. Okay, the content, structure requirement, the frame. Okay, this is a kind of mix between requirements and definition and the PBS, the breakdown structure of the system to be developed. Okay, so that's it. This just a demonstration of how this technology can make it so easy to interconnect to whatever other tool. The only thing left is which tool. You decide which tool, and you have to create the generator of the owner of the tool has to create the SRL instance. So this index example is a consumer, which is ready in the AMASS platform. A consumer, that's what I wanted to do to demonstrate this. But this is how it works. You generate or someone generates the generator, and here within the AMASS platform we have the consumer, and this demonstrates everything from every side. Okay, and just to review, this is the loop, and our target goal for P2 is this: to do it, but with our own tools. Okay, in both directions, from AMASS and to AMASS. Okay, it has been like 10 minutes or something. Okay, questions?
Yeah, maybe two questions from AIT. One regarding
yes.
slide number 7. There was something maybe we have misunderstood, but you see this app. Yeah, the artifact has a relation with.
Here, yes.
Yeah. So on the top left of the artifact, where does it really come from?
Top left.
Yeah.
The thing is that the artifact is the instance of something. It's our container, okay? As the main container, let's say. The first one, For example, I tell you what is our idea with this. As we said this morning, we want to have in AMASS the the results of the quality, the requirements, or requirements, or any other workflow model or whatever, but just without losing generality. For example, requirements. We want to insert in the AMASS platform the result of the quality assessment of your requirement specification. So we can generate an artifact. We can generate, an instance of this model saying this is the artifact quality for your specification, whatever. Okay, whose artifact type is quality specification, quality requirements, quality analysis. Okay, in this side. In this side here, this is a type of requirements analysis type. Here is the artifact, this is the container of all the assessment, and then we will start populating this container or artifact with the information coming for example, for this metric, I have this value. For this other metric, I have this other value. For this metric, I have this other value, or something like that. And for example, there is a relationship with another assessment of other specification, and we have found that there are some traceability links that are missing between this one and this one. So we can generate relationship between this assessment and another specification assessment. This is something we are researching right now, but it with this meta model, you can express whatever kind of information you want. In fact, it's a simplification of our universal model to represent information. It's a slight simplification to make it easier for you to create generators of this kind of language. Okay? Did I answer your question?
Yes, thanks very much. The question, we were just wondering because we thought that the connection from the artifact to itself, we already thought that maybe an artifact can consist of multiple artifacts, yes. but we thought that it maybe be an error. It would be false because the line of the aggregation is not directly connected to the artifact. It's inside, right. So we thought maybe it would be false.
No. You have this one. Okay, yes. An artifact can, let's call it container if you want. A container can be a set of containers, depending on the information you want to represent.
Yes.
That's it. Yes, yes. And you can have another loop, another recursive instance by means of relating something, which in the end it's a term, it's a name, for example, that can be artifacts. Okay, it can be a final term or another artifact composed of many relationships, some other terms, some other meta properties, and so on. You can instantiate and in depth as many artifacts or containers that you want to represent the information as you want. In fact, we have two systems. If you had a look at what Eugenio displayed this morning about the requirements quality assessment of a model, we have a strong discussion because we use this representation to get information from models. We have a strong discussion in how to do that because there are several possibilities. One, let's say, plain read of the content, so we have only one artifact and a lot of relationships in that artifact, okay? Or we can artifacts within artifacts, representing more precisely what is inside the model. So, in fact, we have generated a lot of parameters you can configure. Eugenio did not show them, all of them this morning, because it was not the purpose of the global approach to our technology and our work in AMASS, but there are many possibilities to tackle the transformation of the information that you want to represent in this and the instance itself. So it depends how you do it. And there is no better representation than the other. It for some reason it fits better in one way, and for the other reasons fits better in another way. So the good thing is that you could do it. You can parameterize it as you want to fulfill your needs. That's the idea. and that this model allows that. That's the idea behind. Okay.
Okay, thanks.
Okay. More questions? No? Okay. Well, thank you very much for attending this meeting. And the last meeting will be on Wednesday next week. I think it's going to be at 3 p.m. So I encourage you to attend it. And thank you very much for joining.
Okay, thank you. Bye.
Yeah, goodbye.
Bye.
Thank you.
Bye-bye.
Thank you. Bye.